So to continue with the synthesis problems, you should be able to do these as well as what's shown here. And what I just realized is that your book actually uses sodium cyanoborohydride rather than lithium. They both do the same thing. They're basically reduces only the amines or enamines, and your book doesn't actually have hydrogen with the nickel reduction, so don't worry about that. And in all these cases, you could swap the sodium for lithium. All right, so just summarizing the reductive amination, obviously with ammonia and primary amine, you're going to get the imine. But if you have a secondary amine, you're going to get an enamine, as you should remember. And in either case, the reducing agent will add the two hydrogens either across the CN double bond or CC double bond in enamine case to give the amine. All right. I think that is, oh, and the other thing that your book has is when you're doing phthalimide reaction, the hydrazine is one way to release the protecting group, or you could just use regular hydrolysis reaction in order to release the protecting group. All right. So all these questions are you should be able to do, and what I have in this table is basically summary of all the reactions that we went over. So Gabriel synthesis is using phthalimide in order to get the amine. This is the azide synthesis to do a nucleophilic substitution reaction to get the amine. And then the reductive amination, which I think is the most useful of the three methods, because you do all in one pot. Basically, you add the aldehyde or ketone, and then you add the amine. And as the amine or enamine is formed, because of the reducing agent is present, it does the reduction, giving you directly in one step the amine. All right. So with and also the reductive amination, you could not only get the primary but secondary and tertiary amine as well, and then after you get the tertiary, you could alkylate further to get the ammonium ion if desired. But notice the azide and the Gabriel synthesis, that method only gives you a primary amine, not a secondary or tertiary. Okay. So as an example, we're going to do two problems, 23.1ab, in which it asks you to synthesize this amine using the reductive amination reaction. All right, so once again, this is the product, and so when you're faced with producing amine, you could choose one of these three, and this is a primary amine, so you could potentially use Gabriel or azide or reductive amination, but this problem specifically asks you to do reductive amination. So that means that the last thing before you got the amine was to reduce with the sodium cyanoborohydride, which means that immediately before that was the amine. So then your question really becomes, how did this amine come about? And that is from the ketone plus the ammonia, and that will give you the amine, and then the reduction will give the amine that is desired. The second synthesis question is 23.12a, and in this problem it asks you specifically to use Gabriel synthesis to make this primary amine. All right, so that means the step right before you produce the amine is the this part is still attached to that nitrogen, because that's the last step in this synthesis. So this nitrogen would be trapped in this protecting group, and you could just easily hydrolyze it to release the imide functional group by hydrolyzing this amide bond and this amide bond. All right, so that's hydrolysis step. So that means you would have gotten this from an SN2 nucleophilic substitution reaction of the this halogen. So this is where the bond you would have made, plus this nucleophile. All right, so the nucleophilic nitrogen would attack this carbon and displace the bromine to give you this intermediate, which would, when hydrolyzed, would give you this, plus, just to make sure you understand, when you hydrolyze, you would get that diacid as the byproduct, right? So that we're not interested in, but this is the product that you would get. So where did this come from? This came from the starting material, phthalimide, which is just protonated form of the nitrogen, and we needed a strong base in order to deprotonate that proton to make the nucleophilic phthalimide ion, which does the SN2 reaction to do this. So working backwards, even in simple problems like this, knowing the phthalimide chemistry, obviously the Gabriel synthesis, and knowing where the nitrogen comes from, it helps to be able to work backwards to give the final product. All right. So before you attempt to do these problems, what you should do is make note cards of all these 3 steps that we went over in a 3x5 card, putting in the front of the 3x5 card the reagents that you need with the starting material, and then in the back writing the product, so that you could do problems either way. If I give you what do you get if you react this with the sodium cyanoborohydride, and then in the back you should have this, so that is covered. You should be able to give me the product, and then you should also be able to test yourself with how you would prepare this, and the answer should be in the front of the 3x5 card. All right, so make sure you're making these cards as we go over. Every reaction should have 2 to 3 of these cards, so you could keep quizzing yourself. All right, so this concludes this unit, and so the unit covered basically the acid derivative, carboxylic acid derivatives, and then the amines. All right.